Howdy, folks, and welcome to another episode of Cedar. Today, I want to talk about context. So here we've got an example schema, which is going to allow us to, check some policies and describes what entities should look like in Cedar. And in this case, it's really easy. We're just saying that we've got, some principals that are students. We've got some resources like exams, and there's only one kind of action, which is view, and it applies to students who want to look at exams. Okay, so only one kind of request really can even type check in this schema. Super simple. But there's another piece of the puzzle that we haven't talked about in Cedarcraft, which is context. So sometimes you'll see this acronym for the kind of requests that are supported in Cedar. Park, so we got principal, action, resource, but there's also this context thing. And context represents facts about the world or the environment that are going on when the request is made. So normally, actions are typically very static. You only have a fixed set of actions available. And principles and resources reflect the state of your application relevant to authorization. So, who are the users? Who are the entities that can perform actions? And resources are what kinds of things can they perform actions on. And these are relatively static, where context is used for more dynamic aspects of the request. Okay, so what do I mean by all that? That's a bunch of words. Let's look at an example and see what we might not like about it. So suppose that, I'm teaching a class and I want to let students view the exam. Well, I can write this policy, which says any principal can view any resource, which will certainly let students view the exam. We can make some entities. We got a student Alice. We've got an example exam here for a course. And if we run it, it will, sure enough, allow Alice to view that exam. So here we just have a little bash script. It's going to use the Cedar command line interface to make an authorization request. And in this case, we're just going to ask if Alice can view the midterm. Here's what that request looks like. Can Alice view that midterm? So let's run that just to set a baseline, and then we'll talk about what what we might not love about this example. So if I run this under that schema, using those policies for that request, Alice indeed can view the exam. So far, so good. But what if I want to restrict when students can view the exam? If I go back to the policies, it's not super clear what I should write. I need to know when the request was made. And there's nothing about a principle or about a resource that tells me anything about when the request was made, right? There's this context. There's things about the request itself that I might want to use when I'm making an authorization decision that aren't reflected in the entities. And so that's why Cedar provides context. So let's look at an example where we've added time to our schema. So it turns out that when you're describing actions, you can also talk about the context that must be provided in order to make authorization decisions about that action. So here what I've done is I've said, okay, well, to make decisions about whether or not a principal can view a particular resource, I need to know the time that request was made. And so now our requests also have to provide context for a time value. Now you'll notice here that we've encoded time using an integer, right? Assigned integer along. Excuse me. So why did we do that? Well, if we go look at the data types that are available in Cedar, we see all of our favorites, Boolean strings, longs, and then we have collections of those things, whether it's unstructured with a set of things or a record that has keys and fields that are other types or entities, or decimal and IP address we'll talk about later. One thing I don't see here is if I look through this list, there's no time. So what we need to do is we need to somehow encode the time so that we can use that as part of our authorization decision in our request. Okay, so now we know we're going to have time encoded as long in the context. Let's look at the policy and see how we represent that. So far up here at the top, we have the exact same thing, right? We're going to allow people to view exams, but under what circumstances? Well, here we're going to restrict the time in the context that allows, this policy to apply, right? So we're going to do this permit when, and now we have a bunch of arithmetic here. So what is this for? Well, because time is just a long, we need to somehow encode the time as a long. In this case, we've just decided to encode the time as the number of milliseconds since midnight. And our policy is that we want to allow students to take the exam between 1 p.m. and 3 p.m. So to make that readable, to encode it, we just say, okay, well, 1 p.m. is how many milliseconds it's midnight. 3 p.m. is how many milliseconds it's midnight, and we want whatever time value gets passed in to be between those, right? So between 1 and 3 p.m., we will allow this request. And this is actually nice because being able to use arithmetic makes doing things like encoding the time in the policy a lot more readable. And now we can actually use that in a request. So let's go look at an example with time. So here's an example request where we've set the time, and this is a time that is in fact within the allowed period between 1 and 3. But just to make sure that's right, let's go ahead and test it. And here what we're going to do is we're going to comment out this old one, and we're going to make that request with the time. Okay, so let's run that. How's that work? That's allowed. Great. If we look at another request, maybe where time is not okay. So here's one where we set the time to 0, so at midnight. We expect that to fail. So if we go back to test, and we test both time okay and time bad, we expect to see allow, deny. Great. So if allow and deny, that worked. It's interesting, notice that the deny says no policies were applied to this request. And that's because the when clause in our actual policies says that this policy only applies when the time in the context is between 1 and 3. So this policy didn't apply, right? So it didn't give a permit. And since no policies gave a permit, Cedar did default deny, and the student could not view the exam, which is great. Now, the other thing to notice, of course, is that it's up to us to pass in the right time in the context. You'll notice that, when I ran the test script here, right, I made these two requests that have different time values in their contexts, right? So like here is request time bad. It says it's midnight. It's not midnight right now where I'm recording, I promise. And if we look at request time okay, it says it's between 1 and 3 p.m., which it also is not between 1 and 3 p.m. here. So it's up to us when we make the request to pass in the accurate time. So, if we were working in a larger application, when we made our Cedar request, we would set the time in the context at that moment. Okay, so what do we have so far? Well, so far we've made our policies more expressive by using context to encode additional information, but there's other things we might want. So here now we can restrict students to only taking the exam between 1 and 3 p.m., assuming that we set the time correctly in our request, in the context of the request when we make it. But I also might want to make sure that they take the exam from a university IP address. And so one thing I wanted to highlight is that there are these additional types in Cedar. In particular, there's this IP address type. And if we go look at it, it turns out that we can encode IP addresses with this IP operator. And there are additional operations on those as well. The one that we're going to want to use is we're going to check to see, is the IP address in the request within a range that we are willing to accept students using for the exam. So let's go look at a couple examples of that real quick. First, we're going to need to extend our schema. So now in addition to time, we're going to have both time and an IP address in the context of our requests. Authorization, when we try to decide if a request for a user to view a resource is authorized. So for the view action, the context has to include both time and IP. And we can update our policies to now include a test to see whether or not the IP of the context is in any of these ranges, right? So here we're saying, well, is the context IP in this range or that range or that range or that range? And I just got these. I went and took the University of Washington IP addresses, right? So I just took all of these, encoded them in Cedar, took like a second. Pretty nice for doing this kind of policy if I want to restrict the IP request. So let's go back to our test script and see how this works out. We're going to comment out these time-only policies and come down to these time and IP ones. And we've got 4 examples. We'll look at them real quick. But basically, we have the first one where we're going to use the time and IP schema, the time and IP policies, and we have a request where the time and IP address are okay. That is, it's between 1 and 3 p.m. And we're going to use an IP address from UW. And then we have other ones where either the time or the IP are bad. And this is just testing to make sure that we get things right. So here's the one where the time and IP address are okay. This is between 1 and 3. This is one of UW's IP addresses. Here we have one where we have a bogus IP address, right? It's a local address. Here's one where the time is bad. It's midnight, even though the address is valid. And here's one where both the address and time are bogus. So let's run that real quick. See how that works. And if we scroll up a bit, we see the first one was allow. This is when the time is okay and the IP is okay. That was allow like we wanted. And for all the others, where either the time or IP address or both are bad, they're deny, just like we wanted. Right. So, the big picture is that we can use context to encode this additional information about requests, things that we don't want to put in the entity store. And I actually wanted to mention that because it's a best practice for using Cedar. We should not use the context to represent things about principal actions and resources, and we shouldn't use principal action and resource to represent things about the context of the request, right? We have both of these things for a reason. It helps with analysis. It helps with separation of concerns. It makes your policies more readable. Will work the way that the users, the clients of your software expect. So that's one thing to highlight. The other thing to mention is that this context stuff works with validation. So I know we've been on kind of a validation kick the past few weeks, but I wanted to also show real quick, if we make a mistake, so here let's go back a couple steps. Suppose that we tried to perform a request with our time schema, right? So what does our time schema say? That's the one that says, let's close some of these tabs. Sorry, folks, got a little cluttered there. Our time schema says that the view action has to have time in its context, right? So if we try to check the static request with the time schema, we're going to get a bug. We're going to get yelled at. So let's look at that real quick. Sure enough, right, this doesn't work. In fact, it doesn't even parse. Right? It says for the static request, let's look at that again. The static request, it does not provide a time value in its context. Right? So the static request, this was that first request we looked at, it doesn't provide a time value. And so under the time schema, the one that says that request will have time, we get an error. And as we saw last week, we should always pay attention to errors from evaluation. We should always look at the diagnostics because if we don't, things can go wrong in subtle and confusing ways. But we saw a bunch of stuff this week, which I think is pretty nice, right? So we saw this way to add schema information about the context. But even nicer, we have these ways of making Cedar policies more expressive by incorporating things about the context when the request is made, including things like the time, including things like the IP address extensions, etc. So thanks a lot, folks. Really excited about continuing to make this content and engage with people. And we will make sure to see you on the next episode of Cedarcraft. Have a great evening.